considering for the fuel. Next is the ethanol. Ethanol is having the energy content increased as compared to the methanol, but flashpoint is also higher compared with the methanol, but it is a low flashpoint fuel. The feedstocks mainly are the crop rich in sugar or starch, corn, sugarcane, beetroot, and etc. Production process are the fermentation followed by the distillation and dehydration. And the various issues are the material compatibility of the fuel storage tank and supply system must be checked. Ethanol, like methanol, has a low flash point, which is below normal boiling ambient temperature. Hence, measures must be taken against their ignition and explosion. So this picture is mainly showing the various terminology, green, blue, and gray for the hydrogen. Uh, the green hydrogen means it is produced from the renewable sources and through the electrolysis process. And the blue hydrogen means it is produced from fossil fuels like coal or methane. Then, but the CO2 captured in this process, but in gray hydrogen, it is produced from fossil fuel, but the CO2 is not captured. LNG is having excellent energy content, which is compared with compared if with the marine fuels, it is higher. However, it is having very less density compared with the conventional fuels. So it is required more storage space. So mainly LNG is produced from the coal or natural gas extracted from offshore fields. It is also produced from the syngas or biomass. The production process is the extraction and then liquefaction if it is stored in a liquid form. So if it is come in a direct contact, if it is direct contact with the LNG can lead to the thermal shock or frostbite to the humans. The excess concentration in the atmosphere can resulting the asphyxiation. Ammonia, ammonia is having the less lower heating value, so energy content is lower. However, the density is comparably higher compared to the LNG. It is mainly produced from methanol, coal, biomass. The production process is hydrogen is combined with the nitrogen using the Haber-Bosch process. Main issues with the ammonia are the toxicity and flammability, as ammonia is having very high auto ignition temperature. It is require the low flame speed and limited flammability range. So for the self ignition, it requires very high compression ratios and temperature, which may lead to the higher quantities of NOx formation.
Mr. Daga,
Yes, sir.
2 minutes.
Okay. So for the hydrogen, it is having the higher flammability ranges from 4 to 75%, and it is stored at a very less temperature. So we need to consider these properties while using on board. For the dimethyl ether is also having a superior energy content, and it is same properties like the LPG, but it is relatively toxic also. So various carbonyl compounds and formaldehyde, acetaldehyde, formic acid are also found to be higher in DME. These are the various technology we are considering of like fuel cell systems. These are the various fuel cell systems, proton exchange membrane fuel cell, then high temperature and solid oxide fuel cell, and these are the various properties of and differentiation between them. These are the various battery systems we are considering: lithium ion, lead oxide, rechargeable nickel, and high temperature sodium. Next technology is we can use the onboard carbon capture from the exhaust gases. So it required to be dedicated liquefied CO2 storage tank, and then discharge of CO2 at a receptor pores. The comparison with the candidate fuels. So if we compare with the storage capacity of HFO with various alternative fuels, so we can say that ammonia and hydrogen is required more than 4 to 5 times more storage capacity. If we are not increasing the storage capacity, then we require more bunkering frequency. So this is the cost term. So LNG prices have gone on significantly within a year because of ongoing war and requirement of higher storage capacity compared to the HFO. So biodiesel generally provides a good balance between cost and volume storage. So these are the CO2 emission considered for the well to wake for the various alternative fuels. The FAME and HVO biodiesel show potential for meeting IMO targets. These are also compared with the HFO, various alternative fuels, ammonia, liquid hydrogen. And liquid hydrogen also demonstrate potential, but needs to be produced using renewable sources. These are the availability of fuels. Availability right now considered methanol and ammonia is less compared with the LNG and conventional fuels. So if we are transiting or transferring to the ammonia, then we need to increase the production of the ammonia and methanol. So availability of marine engine, mainly present day marine engines are marine engines may be amenable to use the blends of biofuels and even need biofuels. And engines using LNG and methanol are already available in the market. Engines using ammonia and hydrogen are under development. Rules and guidelines covered are for the low flash point fuels, IGF code and interim guidelines. They are already developed. These are the various rules and guidelines developed by the IRS for the battery-powered vessel fuel power installation and for the ammonia fuel ship guidelines under development. Mainly key takeaways. We need to consider the well-to-wake approach for the GHG emissions. Alternative fuel production on the present day may not be sufficient completely to do away. And biofuels have less impact on the storage requirements, can be used in the present marine engines. However, sustainability and demand from other sectors is to be explored. LNG at present is a fuel which help reduce CO2 emissions to an extent. However, in the long run, options have to be explored to generate LNG from biomass. Ammonia appears to be useful candidate as an alternative fuel. This will also depend upon the technology available on board. Onboard carbon capture may be a good interim solution. This would also call the reception facility at the port and infrastructure to dispose of CO2 at land or offshore sites. Thank you.
Thank you, Mr. Daga. You have lost 10 minutes of your lunch time. Um, uh, it was a very interesting presentation. Thank you for you showed us 10 types of fuels that are likely to be on the situation or scenario for us to use. You've showed us technologies and you have showed us options. I would now like to invite Mr. Atta Das to present his views on the applicability of biofuels as a marine fuel. I'm trying to use the 4 very interesting papers submitted to set the tone on what are the type of fuels. We started with it. We're going to look at what is one particular fuel which looks very prospective. Then when we are looking at one future fuel that could be challenging but is most sought of tomorrow. And then we are looking at how a transition methodology can be used. So that is the floor, how I'm setting this technical session. I would like to ask Mr. Pata Das to introduce Mr. Das. He is the Regional Manager, Operations Manager for Fuel Oil Bunkering Advisory Services connected with Lloyd's Register Shipping. Lloyd's Register, sorry. He's a qualified mechanical and marine engineer with a degree in mechanical engineering, having more than 20 years of experience involved in sailing as a chief engineer on various types of vessels. He is presently managing the LR Phobos service delivery in Asia. He is a member of the Singapore Shipping Association, the Bunker Subcommittee, and he's also a part of the Singapore National Mirror Committee, MMC, under the ESG Standards Development Organization. Mr. Parthadas.
Thank you, Mr. Kashyap. And good morning, ladies and gentlemen. So I hope Mr. Daga have given a very good comparison of the different fuels. So I have a time, this thing constraint, I know, so don't want to go much. Phobos is a part of LR. So why we have a lot of these things of the climate change? COP have just had a meeting in Egypt. We have a target by the IMO to reduce the CO2 by 2030. There is also a reduction by 50% by 2050. Then you have the CII coming into the next year. You have a CII factor. So a lot of ship owners are involved. How to reduce the CO2? A lot of rich ship owners are doing R&D with methanol, with ammonia. And ammonia is so corrosive. And Mr. Daga is given, the calorific value is so low. You need a huge storage. LNG vessels, a lot of ship owners are not using LNG. The cost is so high. They are using distillate. So one of the best option to go ahead is the biofuel. And especially a lot of the whole industry is supporting in the biofuel. I was in the working group on the ISO. ISO is coming with the new specs in 2024 for the biofuel. Then you have the IMO also supporting out. They reduce the NOx for these things for the biofuel. So the whole industry is supporting to promote biofuel. So biofuel, there are various types into it. The first generation, of course, we had the rapeseed, sunflower oils, and other things. So a lot of the industry were telling that, okay, you are wasting, maybe creating shortage on the food industry. But the second generation you have is used cooking oil. A lot of the suppliers are using used cooking oil to supply. There are a lot of good suppliers in the ARA region supplying these things, biofuel from the used cooking oil. Then the third generation or the second advanced generation is coming from the waste product, biomass, like algae and other things. And when we have this thing, it will be a total game changer. What are the benefits you have? A lot of these things, trials are done by the sheep owners. And the trial run, the records are absolutely very good. It meets the IMO regulations, reduce the CO2 content, and is the convenient drop in fuel. You do not need much modification. I'll go into details in the next slide. What are the changes required? The ship trials, absolutely very good. We have done a lot of ship trial from LR side with a lot of the ship owners across the world. And the trial records are very, very good. We can see the CO2 emission. As we increase the B30 is the percentage of the FAME. So as you go the FAME percentage, the biofuel percentage goes, the CO2 emission gets dropped. See the B50, it gets more lower. And the process of production of biofuel is very, very, very easier. It doesn't take much cost. Basically, you have the vegetable oil, which is mixed with alcohol and the catalyst. You have they call it the esterification process. On the esterification process, you have the product is the FABE. What are the challenges? Of course, there are some challenges. You cannot have straight away that. The most important challenges is oxidation stability. You cannot store too long. Especially, normally we recommend is use by 3 months. If you want to use more than 6 months, maybe a big challenge. So try to use within 3 months. The second is because it's a vegetable products, there's a tendency of microbial growth, microbial activity. So what we suggest how to prevent is when you take the storage, use a biocide to clean up the tank. That can help to prevent the microbial activities. It tends to retain water. So once it tends to retain water, there is a chance of microbial contamination are higher. So you need a regular drainage of, especially during the use, the drainage of the settling tank and the service tank. Regular drainage are required. The calorific value are slightly lower. It's not that much compared to ammonia or methanol, where it is much lower. But for biofuel is slightly lower, so the fuel consumption may be slightly higher. Material compatibility. I will go into a little bit details in the next slide on the material compatibility. Of course, some biofuel are solvent nature. It tries to make sludging, but that's for a short period of time because it does the cleaning action of your tanks. Cold flow properties. Some biofuel have higher CFPP or pour point. But that can be prevented if you do add additives. You can lower the CFPP. You can see the comparison, like for VLSFO, the calorific value is 40.91, and for B30 is 39.92. So it's slightly lower, which maybe the fuel consumption will have a more fuel consumption. But compared to methanol or ammonia, it's much better. Yeah, the challenges are these things, material compatibility. Okay, we in Singapore, we had tried a barge we have run for 12 months with MPA, these things. And after 12 months, we used B30. After 12 months, we saw the O-rings got changes. So basically, you need to change the rubber O-rings to Teflon coated or PTFE O-rings. That if you are using up to B30, should not be a problem. If you are using more than B30 to B50 or higher, you have to change especially the brass and bronze impeller or the bushing in the pumps to stainless steel. So these are the two modifications required. Other than that, absolutely no problems. The specs, at the moment, there's no specs for biofuel, right? The ISO is coming up with the new specs in 2024. So biofuel at the moment, if you can see, there are different types of biofuel out there, but mostly in the marine use we are using is FAME. FAME is the most common one. HVO is another one which are used, but it's slightly more expensive. It's mostly found in the ARA region, Rotterdam area, but other parts of the world, you don't get much of the HVO. So it's more is the FAME. Good Fuel is another supplier of the FAME, this thing. As I told you, ISO is coming with the new specs. In Singapore, we already published the new specs. There was a SIPCON conference. I was in the working group. So we already have a specs for biofuel. You can purchase the specs. It gives you a very good guideline on the specification of biofuel. For the analysis, of course, the most important part is you have to do the full routine analysis as per the ISO standard. What we suggest to do another additional test is the FAME test, because the COQ maybe you get the FAME, but it may be higher or lower. So we always recommend to do the FAME test. Another test which we recommend is the calorific value, because the normal ISO